Good morning, children. Today we are going to start the chapter Rotation and Revolution. In ancient time, people used to observe the sun rise in the east and reach to zenith and set in the west, and the earth remains stationary. Later, in 16th century, Copernicus proved that Earth moves around the Sun at the same time rotate on its axis. According to his theory, Earth has two motions, that is rotation and revolution. And children, you are very much familiar with these words, rotation and revolution. Now we will start with Earth's rotation. What is rotation? It is the spinning of the Earth on its axis, and the direction in which it rotates is west to east. And the time for one rotation is 12 hours 56 minutes 4.09 seconds. Now Earth's rotational axis is 23 degree 30 minutes, and the speed with which it rotates is 1670 km per hour, and this speed decreases towards the pole. And if we talk about its inclination, I have already told you the earth is always tilted in the same direction towards the pole star as it moves around the sun, and the angle at which the earth is tilted, that particular angle is known as the inclination of the earth's axis. Now let us talk about the effects of rotation on Earth. Now the rotation of the Earth is responsible for the alteration of day and night. Now the rotation of the Earth is also responsible for the difference in time between different places on the Earth. The difference in time is 4 minutes for each degree of longitude. Now, due to the rotation of the Earth from east to west, the sun, the moon, and the planets and the stars appear to move from east to west across the sky. The sun appears to rise in the east and set in the west. How? The apparent movement of the sun and other heavenly bodies are in a direction opposite to that of the rotation of the earth. This is similar to what you observe through a window of a moving train. The trees and the houses and the fields on either side of the railway track appear to move in the direction opposite to that of a speeding train. So in this way, as we can observe through this example, we can understand why it appears that the sun appears to rise in the east and set in the west. We know the sun is stable at one place, but the earth is moving. The rotation of the earth is considered responsible for slight flattening of the earth at the two poles. You have seen, you know that the earth is flattened at the top and it is bulged at the equator. Why? Because of the centrifugal force. Now, Coriolis effect. The rotation of the earth causes a deflection of wind and ocean currents from their normal path to right of their course in the northern hemisphere, and to left of their course in the southern hemisphere. This deflection is due to the effect of Coriolis force. Now the occurrence of tides in the ocean twice daily and their westward progress are the result of rotation of the earth. So these are the effects of the rotation of the earth. Now, inclination of the Earth's axis. The Earth's axis is not vertical. It makes an angle of 23.5 degrees with the vertical and 66.5 with the plane of Earth's orbit. If the axis was not inclined, every place on earth would have 12 hours of day and 12 hours of night throughout the year. There would be no seasons. Now let us discuss the effect of inclined axis on the duration of day and night. Now for this, you have to look at page number 26. There you can see a figure 3.3. Is given, that is inclined axis. You can see the earth's inclined axis. We can see here one yellow part is there and one red part is there, and sun's rays is falling. Can you see that diagram? In this particular diagram, we can see the north pole is completely lighted, means that the yellow part is the lighted part and the other orange part is the darker part. Now in the yellow part, you can see the north pole is completely lightened and you can see the south pole is totally dark. So when this side of the earth is tilted, you may say that it is the side which is facing the sun's rays. That particular area is lightened and the other part that does not receive the sun's rays is totally dark. Now at the equator, the length of the day and the length of night is equal. You can see O to C and C to O to C dash. You can see the length is equal. That means the equator has the equal length of day and night. And on the Tropic of Cancer, you can see the days are longer and the nights are shorter. Then coming to the Tropic of Capricorn, here the days are shorter than the nights. See, you can see the days, that is Y2D, that particular area is short, and Y2D dash, that is that area is long. So Tropic of Cancer, Tropic of Capricorn, here the days are shorter and the nights are longer. Now coming to the Arctic Circle, the day, they have 24 hours of day in the North Pole, that is lighted for 24 hours, and they face the total summer season. And in the Antarctic Circle, you can see night for 24 hours near the South Pole. So it has continuous darkness and winters. Now, why this difference is there? These differences are there because of the inclined axis. If the axis was not inclined, every place on earth would have 12 hours of day and 12 hours of night throughout the year. There would be no season. Now, due to the inclination, when it is summer in the northern hemisphere, it is winter in the southern hemisphere and vice versa. So these are the effects of inclination of the earth's axis. Now coming to the revolution of the earth. A revolution occurs as the earth moves around the sun, called the annual motion. Now time for one revolution is 365 1/4 days, 8,766 hours. This is adjusted after every 4 years. That is called the leap year. Now the speed of the revolution is not uniform. When the earth is closer to the sun, the gravitational pull makes the earth move faster, and when it is away, it moves a little slow. Now the earth's axis is always inclined to its orbital plane at an angle of 66.5 degree. The motion of the earth is from west to east, or in the same direction as the rotation. Now coming to the effects of revolution. Now first we will come to seasonal change. It affects the seasonal change. Revolution causes different seasons, that is changing weather conditions due to differences in heating of the earth. It means it depends upon the angle at which the sun's rays reach it. When the place receives vertical sun rays, the place gets hot. So we already know that the tilt of the earth's axis causes the seasonal changes. Now revolution causes different seasons, that is the changing weather conditions due to differences in the heating of the earth. Revolution is actually an annual cycle. So the seasons repeat year after year. And also, since the earth is tilted, the seasonal changes are not abrupt. Now let us discuss the perihelion and aphelion positions. The Earth's orbit is the path along which the Earth travels around the Sun. Now this path is elliptical in shape. Due to this elliptical orbit of the Earth, the distance between the Earth and the Sun varies. Now to understand this in a better way, come to page number 27. There is a figure 3.5 given to you. Now just have a look at this figure. When the earth is closest to the sun, the position is called perihelion. Now this position you can see here in the picture on 3rd of January, it is 147 million kilometer, that is closest. It is closest to the sun. Now coming to the aphelion position. At aphelion, the distance of the sun is 152 million kilometer. Now this at this particular position, it is the furthest Earth is furthest position from the sun. So this particular position is known as aphelion position. Now let me explain you the solstice and equinoxes. Now first the solstice. After 21st March, there is an apparent movement of the sun to the north of the equator. This apparent northward movement of the sun in the sky continues up to 21st of June, when the sun appears overhead at the Tropic of Cancer, that is 23.5 degree north. The sun appears to stand still at this position and then moves southward towards the equator. The position of the sun on 21st June is called as summer solstice, and it marks summer season in the northern hemisphere. And on 22nd December, the southern hemisphere is tilted towards the sun, while the northern hemisphere is tilted away from the sun, and this is known as the winter solstice. On this day, the sun is overhead at the Tropic of Capricorn, that is 23.5 degree south, and it marks winter season in the northern hemisphere. Equinox. On 21st of March and 23rd September, the sun shines vertically overhead at the equator on both these dates. This angle decreases as one moves away from the equator. On these two dates, the days and the nights are equal. On 21st of March, it is spring in the northern hemisphere, and on 23rd of September, it is autumn. Now this position is reversed in the southern hemisphere. Now the angle of incidence, the altitude or the angle of incidence is measured in degrees. Now how is it calculated? It is calculated by subtracting the value of latitude, supposingly x degree, from 90 degree, that is 90 minus x degree. Supposing the latitude is 60 degree, then 90 degree minus 60 degree. So the angle of incidence will be 30 degree. Now seasons and duration of day and night. Now during the equinoxes, all the places on the earth have 12 hours of day and 12 hours of night, that is equal day and night. Due to the revolution of the earth round the sun on an inclined axis, the duration of day and night varies according to the season and the latitude of a place. Now position on 21st June. Now on the summer solstice, the north pole is inclined towards the sun. Therefore, the duration of sunlight or daytime increases from 12 hours at the equator to 24 hours at the Arctic Circle and beyond. And on 23rd of September, the sun is vertically overhead at the equator and the days and nights are equal. It is autumn in the northern hemisphere and spring in the southern hemisphere. Now the duration of sunlight is 12 hours on all the places on the earth. Now for understanding it in a better way, in the last slide I have last second slide, you can see I have given a picture is there. You can, if you watch that picture, you can understand this in a better way. Now the position on 22nd of December, Earth's position on 22nd December. On 22nd December, the southern hemisphere is tilted towards the sun. It experiences summer. Now areas beyond the Antarctic Circle experiences 24 hours daylight. Now it is summer in the southern hemisphere and winter in the northern hemisphere. Now if we talk about the position on 21st March, the Earth's position is After 22nd December, the sun again begins to move towards the equator, and on 21st of March, the sun's rays fall vertically over the equator. So on this day, all the places on the earth have equal days and night. So during this period, it is spring in the northern hemisphere and autumn in the southern hemisphere. In the next slide, you can see that picture. Through this picture, you can understand it better. So that's all from this chapter.